This conference will now be recorded.
Okay, so last class we started about this HDFS, and within the HDFS we discussed about block size, replication factor, and metadata. And after that we have defined what is exactly Hadoop. I mean, what is the definition of Hadoop in a simplified manner. And then we discussed about different process names and their respect to RPC ports and HTTP ports. And I have given you overview what exactly each and every process name is doing, right? So let me represent it and we can go for further. Okay, so now if you go for Hadoop, so Hadoop is having two components. One is HDFS plus MapReduce. Right now within HDFS, what are the process names we're having here? Process names, right? Process names. So here we're having name node, data node, and one more thing is secondary name node, right? Now if you comes under MapReduce, job tracker, so we're calling as resource manager, and here we're having task tracker, so nothing but node manager, right? And here comes under RPC port, nothing but remote procedure calling, right? So RPC port. So if you comes on a name node, what is the port here? 8020, and that node we don't have, and even second name node as well. Now if you comes under job tracker, it is having 8021, right? Okay. So now here comes under HTTP port. HTTP port. So here for name node, what is the port here? 50070, and for data node 50075, and for second name node 50090, for job tracker 50030, and for task tracker 50060. Okay, and what is the main importance of name node here? Storing the metadata. Storing the metadata, right? Storing the metadata. Now if it comes under data node, it will store the actual data. In our point of view, we're calling as a blocks, right? Storing the actual data. And now if it comes under secondary name node, secondary name node, backup of name node metadata, but not for process backup. Okay, backup of name node metadata. I mean, whatever the metadata in which it is having my name node, same metadata it is going to store in secondary name node as well, but not for process backup. What is exactly process backup we will discuss within short time. Okay, now if it comes under resource manager or job tracker, so that is assigning job tasks to task tracker or node manager. Just is going to assign some tasks. Okay, now if it comes under task tracker, so executing the job tasks given by job tracker, or we can call as a resource manager, and send responses back to job tracker. Okay, execute the job task given by job tracker and send responses back to job tracker. So here, whatever the jobs which is assigned by job tracker, that jobs is going to execute by task tracker, and finally we're going to get some response, right? That whatever the response which is got by task trackers or task trackers, it will send the response back to the job tracker. Yeah. So this is nothing but what is exactly some brief overview of each and every process name. Okay. So you have asked one doubt, right? So what is metadata about? What is the exact metadata mean? Sudesh?
So,
You mean what is metadata?
yeah, I'm not sure about what kind of metadata is going to store over there.
What kind of metadata means?
Means
You
you
mean
have,
you're asking about? Yes.
yeah, what kind of metadata
Yes.
will
Tell me.
Hadoop store? Did you get my question?
No, exactly.
Yeah, actually, you said this name node is going to store metadata, right? So, metadata about which component it is going to store, or what kind of data will
No,
be
no.
there.
If you yes, yes. So if you observe the, let me explain you with the architecture. Okay. Okay. So I will clarify your point very soon. Okay. So let me explain you further. Okay.
This conference will now be recorded.
Okay. So now if you observe, here we're having some RPC port, nothing but remote procedure calling. What exactly this RPC? So now we're going to discuss. Now we're going to get a complete idea about, I mean, what is the exact difference between RPC and HTTP port. Anyway, you have seen this. I mean, we have started the Hadoop and we have accessed the Hadoop, Apache Hadoop UI by using this respective port as well. But now we're going to get a complete picture about RPC port and HTTP port. So let me explain you with some example so that you're going to get complete idea. So now here just assume that it is Axis Bank. Axis Bank. So Jubilee Hills branch. Jubilee Hills branch. Okay. So here, what is RPC here? Remote procedure, right? So within the Axis Bank, what is the structure we're having generally? So okay. So assume that he is a manager of Axis Bank. Okay. So here we're having some different departments, maybe some credit card department and uh, house loan department, personal loan department. Okay. Uh, what are the different departments we're having? Maybe some gold loan departments, maybe some vehicle loan department. So like this, just assume that we're having some multiple departments within this branch, and manager is the head of the branch. Anyway, we know, right? So now let us assume that, okay, so manager want to communicate to some this housing loan department or maybe some gold loan department. Any of these departments, just manager want to communicate. So is manager is going to come to each and every department here? It will not happen, right? So generally manager will not come. Whatever the departments they are having, maybe some head of these departments again need to go to manager. Generally this is the process, right? So he is having a separate cabin. So whether if a manager want to communicate to any of these persons means, so generally manager will not come, these persons need to go to the manager. But how this communication is going on, so if you observe, so each and every department is having a individual landlines. Each and every department is having a individual landlines, and even this manager too. So and they will connect by using a LAN network, right? Local area network. For suppose, okay, once if this LAN network is done, okay, so for suppose if manager is typing some one, so it will be communicate to credit code department. If he is pressing 2, right, maybe it will communicate to gold loan department. So like this, so once if we pressing 1 2 based upon the respective codes, what are the codes is having, it will communicate to each and every departments, right? So now as a end user, for suppose I'm having some account within this Axis Bank, let us assume. So if I want to communicate to this Axis Bank Jubilee Hills branch, right? So as an end user, so he, let us assume that he is end user. Okay, now this person want to communicate to Axis Bank, right? So whether, for suppose, if he's typing some 1 or 2, is it going to communicate? He will not communicate. He was, first of all, he was unable to communicate with this any of this branch. Okay, so generally each and every branch is having, he is associated with some land number, right? Some number. So if this end user type this respect to number, so definitely it will communicate to any one of the members of this Axis Bank, right? So now he is going to get some services from this respective branch. This is the simple process what we're having in this respect to banks. What are the banks? Okay, simple. What is the simple process here? So if manager want to communicate means, so manager is going to each and every department is having some individual land phones including the manager. If manager want to communicate to any of this department means, so based upon the codes, what are the codes is having, so if he press 1, he is going to communicate to credit card department. If he is press 2, so he is going to navigate to gold loan department. So like this, so they're having a some meaningful communication is there. That's nothing but what we are calling as a LAN, local area network. As a end user, so if you want to get some service from the Axis Bank, right? So we're unable to use these numbers here. What are the numbers in which they are communicating internally? So generally they were going to provide some landline number. So where you can get some information from the Axis Bank. Okay, this is the general process in which it is happening, right? Same way here, if you observe this diagram, I have mentioned this RPC port and HTTP port, right? So here, assume that we're having some, instead of manager, we're having some name node instead of manager. Otherwise, instead of manager, we're having some name node. And here we're having some couple of data nodes. Couple of data nodes. And here we're having some assistant manager, general managers as well, right? So that these things are nothing but second name node and job tracker or resource manager, anything currently. Okay. And within the data node, here we're having concept called as a task tracker. So once if I explain the architecture, you're going to get some idea. Okay. So now if this name node or maybe some job tracker or secondary name node, if they want to communicate internally, okay, if they want to communicate internally, so that communication is nothing but RPC, nothing but remote procedure calling. Okay, so based upon this respective ports, what are the ports which I have mentioned you, right? So name node is going to communicate to job tracker and job tracker will communicate to the name node because they're having a RPC ports. Anyway, each data node it has to communicate to name node. So why it is going to communicate, we will discuss later. But currently, what are the communication between this name node, job tracker or job tracker name node, how this internal communication is going to happen between these process names. That's nothing but what is exactly RPC. Okay, as an end user, right? If I want to know, so how many files are stored, right? Or what is the, like, how many, what are the file names which in which it is already stored in HDFS or within the Hadoop, right? Or what is exactly name node is doing, whether it is fine or not, or got any problem with this name node. So if I want to get some information about these process names, right? Here we need to use mechanism called as a HTTP port. These are the predefined ports, right? If you observe these lambda numbers, 040 something, that number is fixed, which is belongs to the Axis Bank, Jubilee's branch, right? Here also by using the HTTP port only, we can get some information about this, whatever the process which is going on. Okay, whether if you want to get some information of name node, we're having some predefined port. So if you want to get some information about job tracker, which is having some predefined HTTP port. So by using these ports, we're going to get some information about this process names here. Okay, this is nothing but what is the difference between RPC and HTTP port. So is this concept is fine, all of you, or any confusion? Fine. I hope this concept is simplified. Okay. So now let us summarize some points based upon this. You mean HTTP ports or RPC? HTTP ports we can change it, but RPC is fixed. So the internal communication within the bank is nothing but LAN. Okay, local area network, LAN network. Same way, the communication between the Hadoop process names, is nothing but RPC. Where is the first point? But as an end user, if I want to get services from Axis Bank, we need to go with either .com or landline. I mean this number 040 landline. Okay. So here also, as an end user, if we want to know some information of name node or HDFS, right? So then we can use these HTTP ports. I hope these points are clear. Okay. So here we're having it two communications. If it comes under Axis Bank, same way that communication just I mapped with our Hadoop point of view as well, right? Hadoop architecture. Now, what are the things which we are discussing? Here we have a name node, secondary name node, job tracker, data node, task tracker, data node, task tracker, data node, and task tracker. Okay. So these nodes, what we're exactly calling as masters. So these nodes we are calling as a syllabus. Okay. So each data node, it has to communicate to name node here. Each data node, it has to communicate to name node, and each task tracker, it need to communicate to job tracker. And second name node will communicate to name node. Okay. So now here, first of all, Hadoop is nothing but a master slave architecture. Okay, and within the, I mean, if these process names, what is the internal communication between these process names is nothing but a RPC communication, which you know already. And here, for suppose for some unknown reasons, if this data node is down, or maybe this data node is down, so how this name node is going to know which data node is going to be down or whether it is running or not? Okay, for suppose if some unknown reason, if that data node is down, so what is going to happen? So these things, how it is going to know by name node is, here they're using some mechanism called as a heartbeat mechanism. Okay, for every 3 seconds data node has to communicate to name node. Every 3 seconds data node has to communicate to name node. Okay, so if it is not communicating for every 3 seconds, if a particular data node, then immediately name node is going to feel that this data node is down. Immediately name node is going to feel that this data node is going to down. That is the reason we are maintaining the replication factor, which I discussed you already. Okay, and here within this data node, let us assume we're having some 1 TB of data, or 1 TB of data is there within this data node. So Hadoop by default, it is following a concept called as a data locality. Data locality means wherever the data is there, there only it need to execute. Okay, so here we're having 1 TB of data is there, so within this data node itself it need to process. Okay, what is the reason? Okay, let us assume here we're having some 4 systems. Okay, so let us assume 4 systems, and each are interconnected, I mean, by using a LAN network. So now within this system we're having some 1 TB of data. How much here? 1 TB of data is there. Just I want to transfer this 1 TB of data from this machine to in this second machine. Okay, in this respective machine. So if I want to transfer means, definitely we need to have some, I mean, we're already having a LAN network, then nothing but by using internet only I need to transfer this 1 TB of data from this system to this system. Nothing but it is a first of all, it is a we can say that it is a costliest call. Costliest call means, so generally, if you want to download some GBs of data, or maybe some 2 GB, 3 GB from internet, means it will take huge time and depends upon your speed as well. Even though here I'm having some 100 Mbps speed, so it will take some minimum couple of minutes, right? But suppose for some unknown reasons, whenever this data is transferring from this machine to this machine, okay? So maybe some network down. So what is going to happen if network down means? So again, we need to, whenever the network is up, again we need to transfer the data from this system to another system from starting onwards. And even there is a, I mean, there is chances of losing the data as well. There are more chances losing of the data as well. But suppose whenever if you are downloading some file from internet, if some unknown reasons, if we have disconnected from internet, right, what is going to happen? Immediately it is going to show failed, right? Here also same way. Even though if you are transferring the data from one machine to other machine, so first of all, it is going to take a huge time. If some unknown reasons, if network is down, means definitely there is a chance of losing the data as well. Or even though if you want to re-upload or re-transfer to one machine to other machine, means again we need to start from beginning onwards. Then it is also a lengthy process as well. So that is the reason Hadoop by default is following a data locality. So what is exact data locality here? Wherever the data is there it is going to process. So here we will have 1 terabyte of data is there. So within this system itself, it is going to process, and finally response will show to the client. That is what is exactly data locality. Okay, so you asked this, what is exactly metadata, right? So here assume that we're having first .txt file. So assume that its size is some 120 MB. So if it is 120 MB, and assume that we're having block size is 64 MB. How many blocks it is required here? All of you. How many blocks it is required? If it is 64 MB, 2 blocks, right? So B1, B2. So now this B1 and B2. So now if it comes under Hadoop point of view, Hadoop terminology, right? So this B1, it is going to store here, and B2, it may be this system. Okay, so by default it's following replication factor, right? So what is the default replication factor here? 3. So same B1 copy is going to maintain, one more copy here and one more copy here, same as well B2 as well. Okay, here also some B2, here also some B2, right? So this is nothing but what is exactly metadata. Okay, so now here we're having, so within this, let's assume some n1, n2, n3 machines. So within this n1, right, what we're having here, all of you, b1 and b2. Okay, n3. So then nothing but what is exactly metadata. This is nothing but what is exactly metadata. So this metadata is which it is going to store here in Hadoop terminology point of view. This metadata it is going to store by name node. So name node is going to know where and all these blocks is present in multiple data nodes. Okay, so for suppose just we have taken as b1 b2, but if you go with the real scenarios, we're having maybe some 20 blocks within this n1, 30 blocks n2, 30 or 50, 100 blocks in n1, n2, n3 machines here. Total number of blocks, it may be some 1000, 10,000, like that. It depends upon our file sizes, what are the file sizes in which we are storing. Okay, so whatever the metadata, I mean where and all blocks are present in a multiple data nodes, and then what is exactly metadata. This metadata it is going to store in name node. So name node, it will not store physical data. So here b1 b2, these are the what is exactly physical data, right? Physical data it is always going to store in data nodes here, but where and all these blocks are present in a multiple data nodes. Okay, logical, we can say that a logical representation, it is going to store in name node. Okay, so is the doubt is clear, Suresh? Yes. Okay, so let us summarize these points. Okay, so then we can go with doubts. Okay, so let us summarize some points. Okay, because concept is deviating, I will clarify each and every doubt, no need to worry. Okay, So what is the first point we discussed here? Hadoop is a master slave architecture. Hadoop is a master slave architecture. What is the internal communication they're using, which we discussed here? RPC communication. And next one is heartbeat mechanism. Nothing but for every 3 seconds. For every 3 seconds, each data node has to communicate to name node. Okay, by using this mechanism only, name node is going to identify which data node is down or which data node is running. Okay, then nothing but what is exactly heartbeat mechanism. And third one is nothing but data locality. Okay, data locality means what is data locality here? Wherever the data is there, okay, there only we have to, there only it is going to execute, or we can say that process it. Okay, so these are the points which we have discussed here. So first one is Hadoop follows master slave architecture. So what is the internal communication between these process names? There is nothing but RPC communication. How data node or what are the data node is running or what are the data node is down, how it is going to down by name node. That is nothing but heartbeat mechanism. That is going to happen for every 3 seconds. And last one is data locality. Nothing but where and all, I mean wherever the data is there. For suppose in system N1 we're having 1 terabyte of data, so within that system one is going to execute or process it. You remember what is exactly data locality, which is going to follow by Hadoop by default. By default this data locality concept is followed by Hadoop. Okay, we no need to do anything. Okay, these are the some couple of points in which we have discussed here. And note point, so name node, secondary name node, and job tracker should be in a different machine in real time. Okay, name node, second name node, job tracker. So nothing but we can say that these process names, okay, we need to configure with a high-end machines. Okay, so there is no chance of what we can say that what we can say, generally we are saying that data node is down, right? So that scenario should not be happen for these machines. Okay, we are unable to I mean high-end configuration means, so it should not be happen at any point of time that machines or whatever the things which are taken, whether it is a machines or laptop, it should not be down at any point of time. Okay, it is highly configured machines here, simple. Okay, now you can have some doubt. Okay, at worst scenario, maybe at some different scenarios, name node is down or maybe some job tracker is down, then what is going to happen? Let us assume name node is down. So okay, if data node is down, task tag is down, nothing is going to happen. These are the cheap hardwares. You can take it as a 500 GB, 4 GB RAM. That is sufficient for this data node and task trackers. But it is not for name node, second name node, and job tracker. We need to take a high-end machine. Some worst scenario, if name node is down, what is going to happen? We are unable to access the cluster. Okay, if name node is down, we are unable to access the cluster, means client is going to get some error. But it is not a, I mean what we can say, that it is not a good, I mean what we can say, so client will not accept this whatever the error he is getting. Okay, whenever the client is accessing this cluster, some unknown reason name node is down means we are unable to retrieve the data and we are unable to display to the client. Nothing but he is going to get some 404 error, some status error, different errors is going to get, which is client is not at all satisfied, right? So that is a reason from Hadoop 2.x version onwards, if some unknown reasons, if name node is down, right? So they're having a one more name node. I mean, what is actually one more name node? We're going to discuss. Not exactly one more name node here. They're maintaining a two things. One is standby name node, and one more thing is a add to name node. So that thing we're going to discuss later. Currently, let us assume name node is running and up. Okay, we don't have the scenario of name node is down. So if it is down, right, what are the scenarios we're having? We're going to discuss in detail. We're having some 4 to 5 scenarios is there. So there you're going to get a complete picture. So you're having some multiple dots here. For suppose name node is down. So we're unable to know where exactly these blocks are present in multiple data nodes. As an end user, we don't know, right? Because that metadata concept itself or metadata is going to store by name node. If name node is down, we also, as a humans, we also don't know where exactly these blocks are present in your multiple data nodes. Okay, so for suppose if this metadata, so that is the reason we're telling that. So this metadata, whatever the metadata which is having in the name node, same backup is maintaining second name node as well. Okay, and if you observe, I have mentioned one statement. Second name node is going to store only metadata of name node, but not for process backup. Process backup means here if you observe, data node is going to communicate to name node, and each data node is going to communicate to name node, but not for secondary name node. Means, so whatever the communication which is going to done by name node for each data node, that communication is not is going to happen with second name node. So if you observe the diagram, second name node will not communicate to this data nodes here. Just it is going to communicate only name node, that is for metadata backup. Whatever the name node metadata we're having, same backup it is going to maintain by secondary name node as well. Okay, so then remember what is exactly process backup. So is the concept is clear, all of you? I mean, what are the concepts which I explained you? So if it is clear, so now we can go with the doubts. So whoever raised some doubts in chat window. Abdul, Amit, Suresh, Rakesh, is the concept is fine? Okay, somebody is having doubts. Sir, one data node is one mission. Yes, one data node is one mission. Okay. Sir, is there any replication of name node? No, here we don't have replication concept when it comes to name node. Okay. Replication, why it is having replication concept is, so there is Hadoop is promising that, okay, at any point of time, means, but suppose we're having some 100 data nodes, if some 5 data nodes is also down, okay, there is no chance of losing the data. Okay, whatever the data in which we're having these 5 data nodes, this data is going to present in a multiple data nodes of different of clustering concept. So within the cluster we're having some 100 data nodes, means if this 5 data nodes is down, the same data is going to present in a multiple nodes, I mean multiple data nodes of same cluster. Okay, at any point of time if client is accessing, means, so client is going to feel that, I mean client is going to get the result, whatever the request is providing is going to get some response from that respective cluster, right? Client also don't know this data node is down, these things is down, but this is an internal mechanism or internal architecture what is going on. I have explained in a simplified way. I mean this name node and this data nodes, how this data node is down, how this is going to down by name node. These all these things just have explained. Okay, is it clear? Amit? Okay. So one more note. If we observe this diagram, if we observe this diagram, data nodes are not communicating with secondary name node. That is nothing but second name node is not for process backup. It will store only metadata of name. Okay, it will store only metadata of name node here. Okay, whatever the metadata in which we are having a name node, same copy it is going to maintain, same replication. So sorry, if replication is different, okay, same copy is going to maintain second name node as well. Okay, so if this name node is down, okay, so what is going to happen? So these scenarios we're having some 4 to 5 scenarios is there. So that scenarios we will discuss in detail in later sessions. Okay, not now. So now itself in discussing means so you're going to get some confusion.